Hello and welcome everyone. This is part 4 of my series of videos about parameter smoothing. In this video I will be testing the updates that I made to my parameter smoothing classes in my last video. Basically put to the test how easy it is to implement the parameter smoothing and also if we can expect any performance gains from that. There will also be some practical examples of the actual sound on this beat. But not now. First I want to look at the code, and I can already spoil you what the code does. It has just a bandpass filter with 3 parameters in this project, and one of them is the cutoff frequency, one of them is the Q factor, and one of them has to do with the smoothing itself because it describes how upsampled the smoothing is. For these things we need a lot of code. Apparently. It is definitely a little bit harder to use this parameter smoothing than the one that I had before, and you will see soon why. By the way, if you are a programmer and you see anything here where you have like a suggestion how it could be done better, then I'm very open for that, because I don't consider this the best solution, especially considering that things are only going to be more complicated when there is more stuff in the project than just a filter. So it all starts with me getting the cutoff value in pitch, by the way. This is a value from 0 to 127, and also the Q value, which is already in the correct form. Then I also get the upsampling order parameter value, which can be a number between 1 and 12 or something like that. I'm getting the upsampling factor from that by doing this. Now I'm getting the cutoff frequency from the cutoff pitch with this function node to frequency hertz with wrap. It just wraps around at 0 and 22,000 hertz. That's just needed in case of different Xen scales where the MIDI nodes 0 to 127 are not within the range of human hearing anymore. You probably don't need that in most projects, but I need that. Then I'm getting the FC value from the hertz with another function and the current sample rate from the oversampler, so nothing too complicated yet. Up until this point, except for this kind of stuff, it would still be pretty much the same as with my last parameter smoothing. Now we have the actual smoothing classes here, the cutoff smoothing and the Q smoothing. So the cutoff smoothing gets the cutoff FC and the Q smoothing gets the Q factor value directly. And now the complicated stuff begins. We have a Boolean filter smoothing, which basically says is either the cutoff currently smoothing or the Q currently smoothing, and only then we go into the first if branch. But let's just assume nothing is smoothing right now because that's the easier branch. That would just mean that we are looping through the channels and then we are getting the samples and also a reference to the current filter of this channel, and then we are doing the filtering. We don't even have to update any coefficients in the filter because obviously nothing is smoothing. That means that also no parameter value is currently changing. Now that is the optimal case, and as you can see for this case we definitely have a performance boost. I don't even have to benchmark this. You can just see that nothing is going on here, so this performs well. Only thing that doesn't perform well here is that there has to be an if statement to evaluate whether or not we want to smooth, but that's still better than having to update the filter for every single sample. So that probably does a lot. Now in the other case that some filter is smoothing, now the weirdness begins because we don't know which one triggered this state. So you still have to find out if it was the cutoff or the Q or both of them. You have to find out for each one individually, and in case that one of them is not smoothing, then you have to fill the buffer with the static value instead of taking the smoothened buffer, so that later when you are continuously updating the filter with the values you can just take the buffer. An alternative solution would be, but I don't think it would be much better, that you just have a lot of if statements here that all have their own loops so that you don't have to fill the buffer. I mean, maybe that's a little bit better because then you don't have to fill an entire buffer with values, but filling a buffer should not be a thing that takes very long because it's basically no calculation to equal something on something else, no heavy calculation at all. I think this is a pretty elegant solution to the problem so far. So we can probably conclude that this parameter smoother that doesn't continuously low pass does have a performance upgrade on the case when nothing is smoothing. But then again, it is even worse when there is something smoothing. So if you expect your users to continuously modulate all of the parameters in your plugin, then you might actually not want to have the new parameter smoother that I just came up with, but just one that low passes every parameter non-stop. But you can never know that, and in most cases, in most plugins, especially the bigger ones, most of the parameters are not smoothened. So I would expect this solution to still be better, even though it looks so complicated. So now the next thing that I want to find out is if it even makes a difference to use an upsampling factor that skips every other sample or something like that. As you can see, that is how it works. It skips a bunch of samples, and only when the sample index lines up with the upsampling factor in terms of dividability, then we are updating the coefficients. So now what I'm going to do is I'm instantiating my project plugin where I always test my template stuff. Alright, so what I'm going to do now is I will choose the randomizer in Bitwig and randomize the cutoff. Now we have randomized cutoff frequency, and I'm making that smooth and moving really fast, like really fast. Now this is ridiculously fast and not very musical anymore, but it's good for testing, because at this speed the rate of the randomizer should be faster than the block size. And we can see I also selected the highest latency here so that I can test if the parameter smoothing is good for big block sizes. And now different Q values could also be randomized if you wanted to, and then it would sound like this. Yeah, sounds pretty reasonable to me. Now we have a really crazy filter that just makes no sense anymore, and we can play around with the quality settings. As I said earlier, whenever I'm going up a value here, then it takes only half the sample indexes of the value below to update the filter coefficients, except when the block just started, then it just takes them anyway. So what we should hear now is that the quality of the parameter smoothing goes down the more we upsample the parameter smoothing. Okay, I don't know if you heard that because it was kind of subtle, but it really got a lot grainier, especially when we reached the 0.9, but I think I could already hear the effect on 2. So what we can learn from this is basically, in my opinion, that there is not much value in upsampling the parameter values, at least not for a filter like this, because the artifacts of upsampling the smoothing can be heard on the lowest upsampling factors, and that's not cool because some people just want to have a very fine control over the sound quality of their modulation. So most plugins, I assume, will not have a quality setting for the parameter smoothing in the plugin. If you want to make a decision how good the quality of your parameter smoothing is, then you might just leave it on top quality at all times, because like performance wise it doesn't make a difference, I think. Let's see. See, I cannot see a difference in this whole line of stuff. It's just the same all over the time. Now, obviously, I cannot really judge about these kind of things very good anymore because of my new computer that is kind of red. Everything performs very nicely on this computer, which makes it a bit harder to still read the DSP performance graph. But I could really not see any difference there, and the only difference was that the plugin was working at all, but not that the quality setting was different. So maybe that would be different if we had tons of filters now, and maybe I should do a separate video about that. By the way, it will take some time until I make a plugin again, because I decided to restart my plugin template project from scratch. I am not very happy anymore with everything looking all the same all the time, and also some structural inner things that, like this template, it got kinda caught up in some legacy code at this point. I don't like it anymore. I want to refresh all the things that have frustrated me over the time and be more open for flexible changes in the future. That would be a nice way to phrase it for everyone to understand. But I try to be quick about that because there are so many things I'm excited to make, and I hope that I'm soon ready to show you all what I mean.